Problem 68, which is one of your homeworks as well. In this one, we have this bar, and we have this roller at the bottom of the bar, and this roller can move on this slot. And we have gravity here too, downward. And the question is, what is the acceleration of point A if we release this from rest? So at the beginning, this bar is in the vertical direction and we suddenly release it. Immediately after releasing it, what's going to be the acceleration of A? So I would say again, think carefully about this problem, spend at least 30 minutes or more, then see the rest of the video. So as always, we need to start with the free body diagram. We are gonna have a normal force at point A, and also we are gonna have gravitational force here. Let's call this point G. And we need to choose a coordinate. You can choose any coordinate you want, but probably this one is gonna be simpler, X and Y. So if I use this coordinate, then I can use, I can write down Newton equations. Sum of the forces in the x direction is gonna be equal to mass times acceleration of the centroid in the x direction. And the only force we have in the x direction is gonna be mg sine of theta in the negative direction. So I'm gonna have negative mg sine of theta is gonna be equal to mass times acceleration of g in the x direction. And same thing for y direction, sum of the forces in the y direction is equal to mass times acceleration of the centroid in the y direction. The forces we have in the y direction is a, and mg cosine of theta negative. So a minus mg cosine of theta is going to be equal to mass times acceleration of the centroid in the y direction. And also the other Newton equation is sum of the moments about the centroid is equal to ig times alpha. mg doesn't make any moments. A is gonna make a moment with the magnitude of a times half of L times sine of theta. And also the direction of the moment is gonna be clockwise. So let's assume counterclockwise is positive. So I'm gonna assume alpha is in counterclockwise direction. So the moment of A is gonna be negative A L over 2 times sine of theta. And Ig is, for a bar, is 1 over 12 ml squared times alpha. Now we have these three Newton equations. And let's see how many unknowns do we have. Acceleration in the x direction, acceleration in the y direction, alpha, and also a. So we have 4 unknowns, but we have 3 equations. So we need more equations. And where those equations comes from, the only thing we haven't used so far is the fact that A is moving along this slot, right? So I need to use this A somehow and relate these a few of these unknowns to that. What's the meaning of that? I can relate the movement of A to movement of A, which means I can write the acceleration of G in terms of acceleration of A. So if I assume acceleration of A, I should actually use a different color because this is not a force. So if I say acceleration of A is in this direction, in the x direction, acceleration of G, which I assumed it is AX in the I direction and AY in the J direction, in these equations, is gonna be equal to acceleration of A plus acceleration of G with respect to A. So I'm gonna have acceleration of A, which is in the I direction, and plus omega cross r, but there is no omega, so I'm not gonna have that one. Plus alpha cross r, so I'm gonna have alpha, which is in the k direction, cross product to ag. But what is this ag in ij form? It is half of L times sine of theta in the I direction, and half of L times cosine of theta in the J direction. Now, I related AX, AY, and acceleration of A and alpha together, right? I relate these parameters to each other. Now, if you look at all of these equations, you're gonna see 1, 2, 3, 4, 5. This is 2 equations. I have 5 equations here, and I'm gonna have 5 unknowns: ax, ay, alpha, a, and also acceleration of a. So I added 2 equations, also another unknown. But altogether, I have 5 equations and 5 unknowns. If I separate I and j terms of this kinematic equation, I'm gonna have ax here is equal to ay. K cross j is negative I, so I'm gonna have negative 1/2 of alpha times L times cosine of theta. And also j terms, here I have ay. In the other side of the equation, I have k cross I is gonna be j, so I'm gonna have 1/2 of alpha times L times sine of theta. So 1, 2, 3, 4, and 5. Most of problems like this, you are going to have many equations and many unknowns. You can solve them manually, or you can use your calculator. It's up to you. I'll let you do that part. You can, for example, find the parameters in terms of just acceleration of A, for example, then put all of them in one equation. There are different ways to solve a system of equations, right? You know that. I'll let you to work on that part. So if you solve these equations, then acceleration of A is going to be equal to negative 4g sine of theta divided by 3 sine squared of theta plus 1. And if theta is equal to 30 degrees based on the problem, if you just plug in 30 for theta, then acceleration of A is going to be equal to negative 1.143 times g.